So in this particular lecture, we are going to discuss the three-phase power measurements. It is an extension for the three-phase system. So as a recap, which we have gone through extensively in the last discussion are that in the three-phase system, the respective phase voltage or currents or even the line voltage and line currents, they are displaced by 120 degree each. Three-phase system is advantageous on account of the improved voltage regulation, higher power to weight ratio and the reduced requirement of the copper conductor. In the three-phase system, the three-phase induction motors are self-starting, whereas the single-phase motors are non-self-starting. So this particular point is in favor of the three-phase system. Now we have gone through the two configurations, star or the delta. Star configuration was also referred as the YWYE. Likewise, the important point here is that the power factor is decided by the lag-lead relationship between the phase voltage and phase currents. So please be mindful that it is related between the phase voltage and phase currents and not related with the line parameters. Likewise, we have gone through the relationship between the line and the phase quantities for the respective star and the delta connection. In case of star arrangement, the line voltage is root 3 times the phase voltage. Line current is equal to the phase currents. Important point is that the line voltage leads the phase voltage by 30 degree. Correspondingly, in case of delta, the line voltage is the phase voltage. Line current is root 3 times the phase current, whereas the line current lags the phase current by 30 degree. So there are the methods for power measurement. They are classified as 3 watt meter method, 2 watt meter method and 1 watt meter methods. So there are the salient points in favor of, let's say, 2 watt meter method. That particular will be discussed there. There are some procedure for the single 1 watt meter method. That particular will also be highlighted. And there are the restrictions of the 1 watt meter method. That particular will also be highlighted. However, as the load can be star or delta, so the 2 watt meter method and 1 watt meter methods are discussed for star and delta configurations. The 3 watt meter methods, so W1, W2, W3 are representing the watt meters. So as suggested previously, that the watt meter is consisting of a current coil that is represented by the thick conductor, and the pressure coil, so that is by the thin, or you can say the coil of the thin wire. Likewise, so current is allowed to pass through the current coil CC represented by M and L, where the pressure coil is connected across the two voltages. Likewise, so as the 3 watt meter methods, so all three IR, IY and IB, they are passed through the current coils of 3 watt meter methods. The voltage or the pressure coil is connected between the phase and the respective and the neutral. So that is VRN, VYN and VVN, that particular will be the voltage. So what we will be seeing that this basically, when we are referring to the voltage R and VRN and the current IR, so basically it is doing the single phase power measurement. So this 3 watt meter method is basically a reference to 3 measurements and each measurement is for the single phase power. Likewise, however, this particular method is possible only for the star connected load because we need the neutral point, which is the star point. This method is applicable, or you can say equally applicable for the unbalanced load. As mentioned previously, that this is just like 3 single phase power measurements. So there is not a victim, and we will be able to analyze it on the single phase basis. Likewise, so let's say corresponding to the R phase, we will be having a voltage, we will be having a current. So corresponding single phase power will be Vp into Ip into cosine of theta, and this, when we will be extending for the 3 phases, it will be coming out to be 3 multiplied by Vp Ip cosine of theta. So here see we have considered the balanced arrangement. However, this particular can easily be extended for the unbalanced arrangement. So in that particular you will be having the expression Vrn Ir into cosine of theta 1 plus Vyn Iy into cosine of theta 2 plus Vbn Ib into cosine of theta b. Likewise. Now we are coming to, because the 3 wattmeter methods, it is coming out to be complicated because of the requirement of 3 wattmeters and the connections. There is, though, that particular method is specifically suited for say the 4 wire connection, which is where say the star point is available or neutral point is available, load is connected into the star array. Likewise. However, the 2 wattmeter method can be extended to both the star connected load and the delta connected load. Only restriction is that the load has to be, or you can say the configuration has to be 3 wire system, or you can say the neutral is not present. Likewise. So it can easily be extended or equally applicable for balanced as well as unbalanced arrangement. What we will be doing, we will be, as the name suggests, the 2 wattmeter method. So we will be having a 2 power measurement, and those 2 power measurements comes out to be corresponding to the 2 line current and the line voltage pair. So that particular, let's say in this example, what we basically we have considered, one of the line Y is taken as a reference. So with respect to that, we will be having say IR and VRY as one pair, and IB and VYB as the another pair. So when say one of the line is taken as a reference, we will not be measuring the current of that particular line. Likewise. So as highlighted that it is extended, it can be extended easily for both balanced and the unbalanced load for the 3 wire arrangement. So that particular is the arrangement. Here say the Y is taken as a reference. So we will not be connecting a current coil of the wattmeter in this. We will be connecting the current coil into the other 2 lines. So that is IR and IB it is measuring. Similarly, the pressure coil is connected. So VRY it is measuring and VBY it is measuring. Likewise. So we will be having that under consideration. So please be mindful that we are measuring the 2 voltages VRY and VBY because we are measuring with respect to the reference Y line. Now the question here is that how these 2 measurements are coming out to be equal to the 3 phase power, how they will be able to give us. So on the instantaneous basis, when say the measurement is done, so we are measuring the IR, VRY, we are measuring another current voltage pair, power through the current voltage pair IB and VYB. So these is VRY is a line voltage of R with respect to Y. VBY is also a line voltage with respect of B with respect to Y. We will be expressing these voltages in terms of the phase voltages. So the expression comes out to be like this. VRY is written as VRN minus V by N. VBY is written VBN minus V by N. We will be able to rearrange these particular terms. So this equation is written into the form IR VRN plus IB VBN minus of IR plus IB V by N. Now this particular is a phase quantity, this is a phase quantity, phase likewise. Now when say we are having a 3-wire system, so the sum of the 3 currents IR plus IB plus IY has to be equal to 0, and from that we can write minus of IR plus IB as IY. So this particular is a resulting equation which is suggesting that it is measuring the 3-phase power. So here say the analysis is carried out for the star arrangement. The similar arrangement can be extended for the delta configuration likewise. Now the 2 wattmeter method. So please be mindful that in our consideration we have considered the Y as a reference. So we are measuring the current IR, we are measuring the current IY, we are measuring the voltage VRY, we are measuring the voltage VBY. So whatever has been marked with the black, that is a phase voltage. Whatever marked with the blue, that is the phase current. Phase current is coming out to be the line current in case of a star arrangement. So they are having a displacement of 120 degree, that particular is drawn clearly. Now Y is taken as a reference, so we have to mark first the VRY. So we will be extending the negative of this Vy likewise and applying the law of parallelogram. So correspondingly with that we will be able to draw the value VRY. This negative of Vy will also be helping us in calculating the VBy by the law of parallelogram. So that particular is nothing but VBN minus VBy. Now what we will be seeing with this, that there is an angle between the VR and IR, that is the power factor angle theta. So the angle between VRY and IR, which are now coming out to be the line voltage and the line current, will be theta plus 30 degree. Similarly, the angle between the other pair, line current IB and the line voltage VBY, is equal to theta minus 30. So that particular is giving us the 2 wattmeter, 2 measurements. W1 is VRY into IR into cosine of theta plus 30. Similarly, W2 VB by IB cosine of theta minus 30. Now this is a line voltage, line current. So in terms of the line voltage and line current parameters, the equation can be resolved like this. So the total power will be W1 plus W2, and that particular is coming out to be like root of 3 IL VL cosine of theta. So this particular is the algebraic manipulation. You will be extending cosine of theta plus 30 like say cosine theta cosine 30 minus of sine theta sine 30 term. Similarly the other term is expanded, so it is resulting into the expression likewise, which is ultimately giving us the value of power root 3 VL IL cosine of theta. Now for the delta connection, the procedure is similar. Only difference which we have to keep in mind, that the voltage VRY is a line voltage which is equal to the phase voltage. VBY is a line voltage which is equal to the phase voltage. However, this particular IR or IB, they are the line currents, so they are to be associated with the phase currents likewise. So IR will be equal to the I1 minus I3. Similarly, IB will be equal to I3 minus I2. So here say you have applied the KCL at R and B likewise. So keeping that particular process in mind, first we have drawn whatever say with the black line, that is the phase voltage. Whatever say the blue line, that is the phase currents I1, I2 and I3. Now we are measuring the IR, which is coming out to be I1 minus I3. So that particular is calculated by law of parallelogram likewise. So that is resulting into the IR. Similarly, we will be measuring the IB, and that particular is coming out to be I3 minus I2. So negative of I2 is drawn, and that particular law of parallelogram is applied like this. So between this, it is another point which we have to highlight, that we are measuring a voltage with respect to y, so we have to also draw a phasor VB by, which is negative or opposite of VYB, like that. So as suggested, the angle between VRY and the IR is theta plus 30 degree. Here say the angle is theta minus 30 degree. So this 30 degree is coming out because there will be angle I between I1 and IR likewise. So on the similar line, you will be able to write the W1, W2 in terms of the line parameters. Now it is needful to understand that when say we are expressing into the line parameter, the equation is coming out to be like this, the way we have obtained for the star connected load. This is simplified likewise. The point here is that in case of the delta connected arrangement, the line current is root 3 times the phase current, where say the line voltage is equal to the phase voltage. So that is substituted. It is giving us the 3 phase power 3 Vp Ip cosine of theta, which is exactly equal to root 3 VL IL cosine of theta. Now the 1 wattmeter method. So previously what we studied, that the 2 wattmeter method is applicable for both balanced and unbalanced arrangement. Why we are able to do that? Because we are having say the sum of the 3 currents IR plus IY plus IB is equal to 0. When say we will be measuring, it is a it can be 1 wattmeter method can be extended for both star and the delta connected load with equal ease. However, there is a restriction that it can be applicable only for the balanced load. Why there is a restriction? That has to be understood, that we will be only measuring one line current IR. So previously we measured the 2 line currents IR and IB, but in this only one measurement is done. So that is suggesting that it is applicable for, you can say, only balanced system. However, we will be taking the 2 measurements. So the current is this much and the 2 voltages, so that particular is coming out to be VRY and VRB likewise. So that arrangement is worked out. So just to facilitate that, we will be measuring the 2 major voltage measurements, VRY and VRB likewise. So it is, you can say, the SPDT switch is connected to facilitate that particular measurement. Now the rest procedure is similar, so that particular is to be understood. We are measuring one common current IR, so that is there. 2 voltage measurements VRY. So just to mark this VRY, we have to draw the negative voltage phasor of minus V by N. Then we will be doing the applying the law of parallelogram. So the 2 voltages VRN and minus of V by N are added to yield the VRY likewise. The other voltage measurement which we have done, that is VRB. So to facilitate VRB, we have to draw a negative voltage of VB, and the law of parallelogram can be applied likewise. So for this measurement, IR and the VRY, there is a angle theta plus 30 degree, whereas corresponding to the IR and VRB, the angle will be theta minus 30 degree. Once that particular is done, we will be able to calculate the W1, W2 likewise. These particular can be expressed in terms of line voltage, line current, and so on. So the 3 phase power is like. So the restriction that we have to understand with the watt method is that it is applicable only for balanced load. However, as such, when say we are doing the 2 power measurements, so you can say it is emulating the 2 wattmeter method. Now for the delta connected load, the procedure is simple. Only thing is that instead of the line voltage, here we have to mark the line current IR likewise. So just to facilitate that, IR is marked as such. So that is coming out to be I1 minus I3. IR is marked. We will be having a measurement between the IR and VRY. So that particular is yielding the theta plus 30 degrees. We will be having say the other measurement VRV and the IR. So to mark VRV, we have to draw it opposite of VVR, and that particular is given. So the angle between VRV and IR will be theta minus 30 degree. And the rest procedure is simple, we will be able to calculate. Now there are say some other salient points which we have to understand regarding this power measurements. So this particular is a summary of the equations W1, W2. W1 plus W2, that is a total power. When say we will be having in this the carefully we have considered the theta minus 30 likewise. So let's say the cosine, when say the angle is smaller, the value will be more. So the W2 is coming out to be, let's say, greater, and that particular is possible when theta is positive. So W2 minus W1 is coming out to be VL into IL sine of theta. So you can make use of this particular sine relation and the cosine relation to yield the identity tan of theta is equal to root 3 W2 minus W1 upon W2 plus W1. So basically with the help of two measurements W1 and W2, you are able to calculate the theta. Theta will be tan inverse of root 3 W2 minus W1 upon W2 plus W1. So theta is calculated, the power factor can be calculated, you can calculate the parameters of the load likewise as if the situation demands. Now there are say some specific cases which we have to keep in mind. The power factor is unity. So unity power factor means theta is equal to 0 degree. When say you are substituting theta is equal to 0 degree, what we will be getting, both the measurements will be of equal value and positive. When you are saying equal value and positive, cosine of theta is substituted root 3 by 2. So basically each of the meter will be measuring half of the power. There is a special case when say the power factor is 0.5. So 0.5 means theta is equal to 60 degree. The power factor can be of lagging nature or can be of leading nature. So because of this, one of the wattmeter will be reading 0, that is certain. However, which one will be reading 0? So in this, when say the theta is positive for the RL load, W1 will be reading 0, because we have considered W1 is equal to VLIL cosine of theta plus 30 degree. However, if suppose say it is a RC load, so the theta value will be minus 60 degree as such, so the W2 will be reading 0 value. However, it is clear that when power factor is 0.5, one of the meter will be reading 0. When say the power factor is 0, theta is equal to 90 degree, so you are making a substitution. So corresponding to theta is equal to 90 degree pure reactive load, the total power will be 0, and that particular is possible when say the meters will be reading equal but opposite value. So that particular is substituted likewise. Further, when say the theta value is between 0.5 and 1. So you please be mindful, the power factor is cosine of theta. So corresponding to the 1, the theta value will be 0. corresponding to 0.5, theta will be 60 degree. So you can say when the angle lies between 0 and 60 degree, the power measurements will be coming out to be positive by both the meters. However, when say the power factor is between 0 and 0.5, so 0 means 90 degree angle and 0.5 power factor, it is 60 degree. So when say that power factor is between 0 and 0.5, or you can say the angle lies between 60 and 90, one of the wattmeter will be reading negative. So these points will be helping you in analyzing the behavior. Now we can extend the 1 wattmeter method to the reactive power measurement. For the 2 wattmeter method, we don't have to do any extra care, because we calculated W2 minus W1 is equal to VLIL sine of theta. So when say we are multiplying this by the root 3 factor, you will be able to get the value as reactive power. In case of the 1 wattmeter method, we have to connect the wattmeter in a special way, and with one measurement we can calculate the reactive power H, or you can say we will be able to get the idea about the reactive power. So current coil is connected with one line and the pressure coil is connected between the other two lines. So that particular is an important arrangement. In this we have connected the current coil with the IR and the pressure coil between Y and B. So with this, let us see how the phasor is suggesting, how the phasor is drawn likewise. So whatever is marked with the black and the blue line, that particular is representing the phase voltage and the phase currents. Wattmeter is connected with the IR, so that particular is there, and voltage between Y and B. So here say it is measuring VYB. So just to calculate VYB, you have to mark a negative voltage phasor minus VB. Once that particular is drawn, VY and minus VB are added by law of parallelogram. So that particular is coming out to be like this. So during this situation, the angle is coming out to be 90 minus theta degree. W is V by V into IR cosine of 90 minus theta. In terms of the line parameter, this is coming out to be like this. Cosine of 90 minus theta is yielding the sine theta. So the expression is like this. When say we will be multiplying by root 3, it will be giving us the 3-phase reactive power by single measurement. Like this. Now there are a few examples which we have to consider to further emphasize the concepts. Let's say it is a 3-phase system of 400 volt. So when it is not specified, this is to be taken as a line voltage and the RMS value. The load is connected in delta, but the line current is 20 ampere and the total load is 10 kilowatt. We have to find out the impedance of each branch, the line current and the power factor. Now the same impedance be connected into the star formation, and we have to find out the load power factor likewise. So for the delta connection, the phase voltage is equal to the line voltage, so that is 400 volt. The line current is 20 ampere, so the phase current will be 1 upon root 3 of the line current. That particular is calculated. So that particular will be giving you the phase impedance, and that is the V phase upon I phase. So it is simply the 20 root 3. This particular is ohms. Now with this particular arrangement, you can extend the analysis of the power value So either with the in terms of the line parameter or the phase voltage parameters, phase current parameter, you can have the value. So the cosine of theta can be calculated likewise. Once say the theta is known, the impedance is known, you can calculate the resistance and the reactance, like say the R is equal to ZPH into cosine theta, X is equal to ZPH into sine of theta likewise. Now in case of star connection, the arrangement is like this. So the phase voltage will be 1 upon root 3 times of the line voltage. Impedance value is same, so the phase current can be calculated likewise. IL will be the phase current in case of star connection. Now the power factor is decided by the physical impedance parameter, so the power factor is remaining unchanged. The power value when calculated for the star connection is coming out to be, it is 333.8. So basically it is resulting into the 3.33 kilowatt. Previously it was 10 kilowatt. So you can say when say the impedance value is the same, the power is 3 times in case of delta in comparison to the star connected arrangement when say the line voltage remains same. Now in this particular example, what we will be having a star connected load which is the phase voltage is 150 volt and the phase current is 25 ampere. The power factor is 0.707 lagging. Now we are assuming that the power is measured by the 2 wattmeter method. We have to find the line voltage, line current, total power and the reading of the wattmeters. So when say it is a 0.707 power factor is given, so correspondingly the cosine relationship is known. You can calculate the theta value as it is coming out to be 45 degree. So the ZPH, that will be VPH upon IPH, that particular is known, so 6 ohm. The line voltage which is asked, root 3 times the phase voltage, and the line current will be equal to the phase current in case of star. So the total power you can measure likewise in terms of the line parameter, or the same can be done with the help of phase parameters. W1 VLIL cosine of theta minus 30 degree, W2 VLIL cosine of theta plus 30 degree. So W1, W2 are coming out to be like this. The third and the last example in this, the input power to a 3-phase motor, you please be mindful here, say the consideration is motor, is measured by the 2 wattmeter method. The reading of the wattmeters are 4.8 kilowatt and 1.6 kilowatt with connection reversed. So this particular is important. Now when say we will be measuring a power in case of wattmeter, when say it is reading negative, so that negative deflection cannot be read, and to facilitate that negative reading we will be changing the pressure coil connection, and that particular is done with the help of DPDT, and this you will be having the experience to do it in the laboratory likewise. But when say the pressure coil connections are reversed, we will be taking that particular reading as negative. So let's say the W1 is positive, W2 is negative 1.6 kilowatt. So the total power, which is the sum of W1 plus W2, is coming out to be 3.2 kilowatt. Now this particular is of inductive nature because it is specified as motor. So the theta will be positive, W1 is coming out to be larger value, higher value, so it is taken as cosine of theta minus 30 degree likewise, and correspondingly the tan of theta you can mark. So the theta is calculated like 73.9 degree, and the power factor is cosine of theta, that is calculated at 0.2774. Now when say we will be having a relation of this particular, so you can calculate the IL, and that IL is coming out to be W upon root 3 VL cosine of theta, and that value is 16.65 ampere likewise. So as a summary, the 2 wattmeter methods can measure power for both balanced and the unbalanced 3-wire system, that particular has been highlighted. 1 wattmeter method can be used to measure power only for the balanced system. 1 wattmeter method can also be used to measure the reactive power of the balanced 3-phase system, even say this particular is done by single measurement. For the specified per phase load impedance, the power absorbed in the delta connection is 3 times to that of the power absorbed in the star connected load. This we have seen with the help of example. The phasor diagram depends on the connection of the wattmeter, how say you are orienting the R by B terminals likewise. However, the end results is coming out to be the same, that particular will be root 3 VL IL cosine of theta. Now there are say the specific cases of wattmeter readings, like say when the power factor is 0, power factor is unity, power factor is 0.5, or you can say when the power factor is lying between 0 and 0.5, 0.5 and 1, likewise they are highlighted. So the power measurement is always expressed in terms of root 3 VL IL cosine theta for both star or the delta connected load. So this summary is concluding the discussion on the 3-phase system. Next we will be going for the DC machines analysis. For further reference you can refer these texts. Thank you.